So we're going to do a little practice here with using what you are given about a situation, right? With sort of a scale model, whether you're scaling up or scaling down. And in this case, we are given both the model length and the actual length. And our mission is to find what the scale is. How much is it changing by? So in this case, we're going to set it up as our drawing or our model to our actual. So we'll say we have an 18 centimeter to 450 meter initial sort of ratio here, right? And we want to know what's the scale factor. So to do that, we want to turn our numerator into 1. To do that, we're going to use a diva, right? And whatever you do to one side of the ratio or to the top of the fraction, you need to do the same thing to the bottom. So we're going to divide both by 18. Well, 18 divided by 18 is 1. And 450 divided by 18, you may use a calculator, is 25. So we know that we have a scale of a 1 centimeter to a 25 meter scale, our factor scale, our scale factor. And so when you essentially have 1 centimeter, which is kind of like a unit rate, right? But it's for scale. We want to know for 1, how many do you go in actual length? So when you go 1 in the model, what does that mean in reality? So let's do another. So over here, we're going to again do our model length to our actual length. So we'll say we have a 4-foot to 250-mile initial ratio. We want to essentially find the scale factor for 1 of our model length. So for 1 foot. So we're going to divide both by 4, the value of our numerator, to turn it into a 1. Whatever we do to the top, we need to do that same thing to the bottom. So 250 divided by 4, use a calculator if you want, is 62.5. So we have 1 foot is equivalent in our model to 62.5 feet of miles in the actual